Mechanisms in motion are short revision videos which show you the effect of arrows in organic chemistry mechanisms. As the format is a quiz, you will be presented with multiple options for how the mechanisms will occur. Based on your choice, move ahead to the timestamp and you will see how your choice affects the reaction. If you are correct, you will move on to the next step in the mechanism. If you choose the incorrect or less likely answer, the reason for this will be explained and then you will be given the correct answer. At the end of the video, you will see the full drawn-out mechanism showing the curly arrows moving the bonds. This video focuses on the amide hydrolysis reaction. Amide hydrolysis occurs when an amide is in the presence of a base. In the first step, the hydroxide ion from sodium hydroxide attacks the amide-containing molecule. Is the hydroxide going to attack the carbonyl in the nucleophilic attack or deprotonate the amide? The deprotonation of the amide by the hydroxide molecule will result in an anion with a negative charge on the nitrogen. While this can occur, acid-base reactions like this are in equilibrium. Therefore, the nitrogen could use the lone pairs to regain the hydrogen, giving you your amide back. This is not the answer which drives the reaction forward. The attack at the carbonyl by the hydroxide results in a tetrahedral intermediate. This intermediate is formed by breaking the pi bond of the carbonyl, making the oxygen negatively charged. This is semi-stable as the oxygen is more electronegative than the carbon. Therefore, this is the correct first step in the reaction. The next step in the reaction is either proton transfer between the amino group and the oxygen or elimination of the amino group by reforming the carbonyl pi bond. Proton transfer from the amino group to the oxygen would not occur intramolecularly or within one molecule. If this occurs, the amino group would be deprotonated by the oxygen of another molecule in solution or a hydroxide group, both options represented by the anion B in the scheme. After this step, you would end up with an alcohol and an amine within one molecule. This, however, is not likely to happen as the reformation of the carbonyl pi bond by amino group elimination forms a more stable molecule than this one. The amino group elimination occurs by reformation of the pi bond of the carbonyl group. In doing this, you need to remove a bond to the central carbon, as carbons with 5 bonds are not stable. Therefore, the removal of the amino group occurs. The NH2 group is removed instead of the hydroxyl group, as the carbon-nitrogen bond is weaker than the carbon-oxygen bond. Also, if you remove the hydroxyl group, you have undone your first step. Now you've formed a carboxylic acid group. However, you still have base in your solution, both excess hydroxide and the amino group. These will react with your molecule deprotonating it. If you deprotonate at position A, you will need to form a double bond. If you deprotonate at position B, you will need to form the carboxylate anion. Deprotonation at position A can occur in other situations. However, the OH of the carboxylic acid group has a much lower pKa, therefore it will be deprotonated first. Also, deprotonation at position A would result in a double bond, meaning you would need to re-break the carbonyl bond you just formed, which does not happen in this reaction. Deprotonation at position B results in carboxylate anion formation. This occurs because the carboxylic acid group is more acidic, meaning it will be deprotonated more easily. If acid is added to the solution after the base, then you will reform the carboxylic acid. This slide is a summary slide for amide hydrolysis, the first step being nucleophilic attack, followed by amino group elimination, then deprotonation, and if acid is present, reprotonation. This slide shows the complete mechanism with all curly arrows as you would need to draw for an exam. Thanks for watching the video. If you found it helpful, please leave us a like or a comment, and subscribe if you'd like to see future videos of mechanisms in motion.